Professional course in English. Process technology. Equipment and systems. Unit 7. Utility systems. In this lecture you will learn steam generation systems, raw water and fire water system, cooling water system, air and nitrogen systems, gas systems, refrigeration system, relief and flare systems. Chemical plants and refineries include unique combinations of equipment and systems that are used to separate materials into pure or relatively pure products. Examples of process systems include reactions, distillation, absorbing, stripping, adsorption, drying, crystallization, evaporation, extrusion, extraction, filtering, screening, utility. Plant utility systems typically include the following operations: steam generation, compressed air and gases, water treatment, cooling towers. Steam generation systems. A steam system is a complex arrangement of equipment and piping that works together to produce and circulate steam at a variety of pressures and temperatures. Because steam is used in so many industrial applications, most chemical plants and refineries have their own steam generation facilities. A typical steam system will include the following equipment: boiler, fire tube or water tube, steam header system, low, medium, and high pressure, condensate return system, steam traps, valves, piping, pumps, deaerator system. In a closed steam system, a condensate return header is used to remove slugs of water or condensate from the live steam line. This treated water collects in low points in the system, where devices called steam traps direct flow back toward the boiler. A vessel called a deaerator is used to collect fluid from the condensate return header. The deaerator is designed to remove excess air from the system. Demineralized makeup water is often added to the deaerator. The cooled condensate is fed back into the boiler, where it is changed into steam. Raw water and fire water system. A storage reservoir, supplied from municipal sources or local rivers and lakes, normally supplies the plant systems that require raw water, which is used for all purposes throughout the plant, and fire water, which is used only in specific units such as boilers, which usually must be treated for purity. Figure 1 illustrates how the raw water system operates. Raw water is supplied to the units in the plant by pumps. All pumps can be remotely started from a utilities unit control service. All raw water lines are located above grade. Plants use raw water in utility station water hoses, process unit fire water hose reels, the cooling water supply, the supply to the fire water system, and boiler feedwater makeup. Fire water is supplied to the plant by pumps, which must be capable of continuing to run if power to the plant is lost. These pumps are typically diesel-driven to ensure operation if electric power is lost. Cooling water system. The cooling water system is used for cooling the various pieces of equipment in the facility in a closed cooling system. The cooling water system is divided into two complementary circuits. One cooling water circuit operates on a once-through basis. The other allows the reuse of water to cool a second train after use for cooling the first train. The cooling water is supplied from the cooling tower to the users by cooling water circulation pumps. Cooling water pumps are typically centrifugal and vertically mounted. The driver can be an electric motor or steam turbine. Make-up water to the cooling tower is supplied from the raw water system. Air and nitrogen systems. Air systems. Utility air and instrument air are both supplied from centrally located air compressors. Drivers for the compressors are arranged so that the loss of power or steam will not interrupt the supply of critical instrument air. Some plants have additional diesel-driven compressors in case the two utilities are not available at the same time. Figure 2 illustrates utility air and instrument air system. Plant air systems. A central utilities unit supplies utility air for the entire plant. Free water is removed at a separator drum that is located off the air compressor discharge but is not dried. Utility air is used for unit hose stations, general use. Air-driven tools. Decoking unit furnaces. The largest use of utility air is in the decoking unit furnace, which is operated intermittently. Usually, an extra air compressor is put online during these periods. Utility air should never be used for unplugging lines or sewers or for removing liquid hydrocarbons from trucks or vessels because of the hazard of creating combustible mixtures. Nitrogen systems. Nitrogen gas is usually generated in the plant or purchased from a supply company. High-pressure nitrogen is delivered to the individual units in a plant. Figure 3. Nitrogen is used primarily as an inert gas for blanketing vessels and lines or for conveying combustible materials and sometimes as a backup for instrument air. Gas systems. Most industrial manufacturers purchase natural gas from suppliers. A high-pressure pipeline generally delivers gas to the plant. Figure 4. Natural gas is used to supplement the fuel gas produced at a unit in order to meet furnace and boiler demands. Natural gas is also used as a purge medium in unit startup and shutdown. Fuel gas generally consists of plant-produced process gas that is augmented with purchased natural gas to satisfy the unit's energy demand. Fuel gas is typically produced internally during normal unit operations. During a startup mode or emergency mode, where no internal fuel gas is available, gas is imported. During normal operation, any excess fuel gas produced is exported by a compressor system. Refrigeration system. Heating and cooling are two important aspects in modern process control. Refrigeration systems such as air conditioning are used to provide cooling to industrial applications. Refrigeration units, Figure 5, are composed of a compressor, high-pressure refrigeration gas, a heat exchanger, cooling tower, a receiver, an expansion valve, low-pressure refrigeration liquid, another heat exchanger, called an evaporator, low-pressure refrigerant gas. In the refrigeration process, low-pressure refrigerant gas is drawn into a compressor, converted into high-pressure refrigeration gas, and pushed into a shell and tube heat exchanger. During the compression process, a tremendous amount of heat is generated and must be removed by the exchanger. During the cooling process, the gas condenses into liquid phase and is collected in a receiver. From the receiver, the high-pressure liquid refrigerant is pushed through a small opening in an expansion valve. As the liquid expands, it changes phase. The boiling point of the refrigerant is so low that a cooling effect occurs in the evaporator. As the low-pressure refrigerant leaves the evaporator, it enters into the suction side of the compressor and the process begins again. Relief and flare systems. Flare systems are used to safely remove excess hydrocarbons from a variety of plant processes. Flare systems are composed of a complex network of pipes and headers connecting to a knockout drum and flare. Figure 6. Flare systems are part of a plant's safety system. Most process units are lined up to safety relief valves that lift when specified pressures are exceeded. These safety valves discharge into the flare header. Unexpected process upsets are dumped to the flare system as a last course of action. A typical flare system includes a flare, a long, narrow pipe mounted vertically, a steam ring mounted at the top of the flare, used to dispense hydrocarbon vapors, an ignition source at the top of the flare, a fan mounted at the base of the flare, used for forced draft operation, a knockout drum with water seal, a flare header. Relief system. The discharge from all safety valves, pressure relief regulators, and operating vents and blowdown valves in hydrocarbon service are collected in a closed piping system and sent to a flare stack. Steam, air, and nitrogen vapors discharge to the atmosphere. Steam safety valves discharge through tailpipes at a safe distance above grade or above the nearest operating platform. Thermal relief valves are provided to protect against thermal expansion as required in liquid full service. The flare and relief systems are designed in accordance with applicable regulations and practices to protect equipment and personnel against overpressure situations. Many units that process volatile hydrocarbons have two collecting systems, a warm-wet system and a cold-dry system. This separation is made to avoid freezing, with consequent plugging due to ice formation of the wet vapors. Both systems go to their respective knockout drums, where the cold vapors are warmed and then combined and sent to the flare stack. To revise the learned material, answer the questions. What process systems are used in chemical processing industry? What utility systems are used in chemical processing industry? What are the basic components of a steam system? What purposes is raw water used for? What purposes is fire water used for? What is cooling water system used for? What is utility air used for? What is nitrogen system used for? What is natural gas system used for? What are the basic components of a relief and flare system?